Hello again, here's question 4 from 2013 and away we go. Here is a table showing length and weight of some bears, and part A we have to determine the power model that fits this data. Okay, we have to put in our calculator in list 1 the lengths L and in list 2 the weights W. And over in my calculator you can see that I've done that. Then to find the power model we just have to use the calc and power regression, list 1 and list 2, and OK. And there it just gives what the answer is. Now I have to, for this question here, it says give the values to 2 decimal places. When that instruction is in the question, you should absolutely make sure that you do that. So I will not use x's and y's, I will use l's and w's because those are the variables given in the question. So we have the equation, instead of y equals, I'm going to have w, my weight, is equal to, now I've got ax to the power b. A is 16.286691. To 2 places of decimals, I look to the third place of decimal, which is a 6, so I round up, and I will get 16.29. Then instead of x I will write my variable, which is L, and to the power b, well, b is 3.7196746. Look to the third place of decimals, which is a 9. That means I will round up and get 3.72 to the power 3.72. And that is the first part finished. Then for the second part, use this model to predict the weight of to predict the length of a 200 kilo bear. Well, the weight is 200, so in my equation my weight is 200, and that equals 16.29 times L to the power 3.72, and I have to find what L is, what the length is. L equals, this is a calculator activity, so I will take you to the main screen of my calculator, and I'm going to use the calculator's solve button, and I get it. There's several ways of getting the solve, but I get it this way: keyboard, calc, solve. There's the solve, and I just have to enter my equation and tell the calculator to do it for me. So 200 equals 16.29. I won't put in L because the calculator is expecting to use x's, so I'll put an x there, x to the power 3.72. And we'll solve that. And we get x is that, or in my case L is that. To 2 places of decimals, look to the third place, which is a 2, so I don't change anything. So x will be 1.96, or L is 1.96, and the units that go with that are 1.96 meters. And now then so the length of this 200 kilo bear is 1.96 meters. To discuss this reliability, well, I've got a 200 kilo bear, 1.96 meters long. Here is my original data. You can see that the length 1.96 is outside that data range. The weight, also being 200, is also outside the data range. Your prediction in general will be unreliable if one of your data points is outside the data range. One of your predicted values is outside the data range. So in this case, both the 200 and the 1.96 meters are both outside the data range, but it would only have taken one of them for this to be unreliable. So I shall just write unreliable prediction because extrapolation has been used. Or in other words, outside the data range. that is that.